Hey AP Physics crew, welcome. Today we are going to crack the code on one of the most important tools you'll ever use in kinematics, the velocity time graph. And trust me, this isn't just about passing your exam. Mastering this is how physicists figure out everything from a rocket launch to how fast a sprinter is running. By the time we're done here, you'll be reading these graphs like a total pro.
All right, let's just jump right in with a question that trips up so many students. You see a perfectly flat, horizontal line on a velocity time graph. So what's the deal? Is the object just sitting there, not moving? Or is something else going on? Have a think about it, because we're about to figure out the definitive answer.
To answer that question, we've got to go back to square one. The fundamentals. Just like with any graph, the whole story is being told by the axes. And understanding what each axis actually represents, that's the absolute first step. Okay, so let's look at the vertical axis, the y-axis. This shows you the object's instantaneous velocity. And that word is key, instantaneous. It's not telling you where the object is, it's telling you how fast it's going and in what direction at one specific single moment in time. Think of it like a car's speedometer. And the horizontal x-axis? Well, that's way more straightforward. It's just time, ticking along. It gives us the when for every single velocity measurement we see on the y-axis. Simple enough, right?
Now, this is where things get really cool. The magic of a velocity time graph isn't just about reading a point here or a point there. It's about understanding what the line itself is telling you. And the biggest, most important clue is its slope.
And there it is. This is the golden rule, the key that unlocks literally everything about these graphs. On a velocity time graph, the slope of the line is the acceleration. If you write down one thing from this whole explainer, make it this. This is the core concept.
And that makes total sense, doesn't it? I mean, what is acceleration? It's just the rate of change of velocity over time. So how does a graph show us a rate of change? Well, it's all about the rise over the run.
You calculate it exactly like you did back in math class, rise over run. But in physics, those words have real meaning. The rise is the change up or down the y-axis, which is our change in velocity, or delta v. And the run, that's the change along the x-axis, our change in time, delta t. So the slope, rise over run, is literally delta v divided by delta t, which is the exact definition of acceleration. See? It all connects.
So, if we know that the slope is acceleration, we can now look at any line on a VT graph and translate it into a real-world story. We can describe exactly what the object is doing.
Let's break down the three main stories you're gonna see. First, if the line is slanting uphill, it has a positive slope. That means positive acceleration, so the object is speeding up. Makes sense. Now, if the line's going downhill, that's a negative slope, which means negative acceleration. It's slowing down. And what if the line is flat? Well, a flat line has a slope of 0, and that means 0 acceleration.
And that brings us right back to our first question. A flat line at 5 meters per second means the slope is 0, so yeah, the acceleration is 0. But is the velocity 0? No way. The graph is literally shouting at you that the velocity is a constant 5 meters per second. The object isn't standing still, it's cruising. It's like a car on the highway with cruise control locked in at a steady speed. So remember this forever. A flat line means constant velocity. The object is moving, it's just not speeding up or slowing down.
Okay, let's pull all of this together into a quick, easy-to-use toolkit. This is everything you need to know to tackle any VT graph they throw at you.
Here it is, your cheat sheet. The y-axis tells you how fast and in what direction. The x-axis is just time. The most important part, the slope is the acceleration. An uphill slope means you're speeding up, a downhill slope means you're slowing down, and a flat, zero slope line means you're moving at a constant velocity. If you can remember these points, you've totally got this.
So now it's your turn. Take a look at this graph. You can see it has different sections, right? Different slopes. Using your new toolkit, I want you to try and tell the whole story of this object's journey. What's happening in that first part? And the second? What about the third? Go ahead and pause and try to actually say it out loud. You have everything you need now to crack the code.